So first, I would like to thank each person here for gathering here and taking time to take place in that event. This event is organized by Studium Generale, which is an initiative created here in Tilburg University, which creates lectures on all various topics, ranging from social dilemmas that are currently most important till everything whatever students feel like it's needed to spoke about, as well as Enigma, namely Student Association for Cognitive Science and AI, as well as data science and society students. That's us. So I will allow myself to quickly give a structure of today's event. Namely, we will have 3 lectures, which each of them will take approximately 20 minutes. In between those, we have got approximately 5 minutes to ask most burning questions. And then, after we are done with third lecture, we will have short discussion panel when we can ask more in-depth and more important questions. So, our first speaker today is Emmanuel Keuleers, whom some of us might know as a great lecturer and great speaker. Aside of that, he is associate professor at Tilburg University at Department of Computational Cognitive Sciences and Research Center for Cognitive Science and AI. In research, Professor Emmanuel focuses on language, thought, and artificial intelligence, how those 3 intersect. And yeah, for us, most important thing that Professor Keuleers will bring today is distinguishing facts and fiction, what in AGI, what is fiction and what is fact. And now I will allow myself to give the voice to Professor.
So, thank you for that very nice introduction. It's my first time doing this. It's not my first time doing everything last minute. So I sent my slides yesterday. Or no, today at 2 a.m. But I hear the second speaker just brought them now, so this is fine. So another thing that I think academics have in common is they never stick to the brief. So I hope that I can distinguish some fact and fiction, but we'll see. Okay. So the title of the symposium that was given is "What if machines outsmart us all?" And it's a provocative question, and I will try to take a provocative point of view, because I think that there will be no shortage of critical points of view towards AI. That's also something that academics are really good at finding reasons not to believe in AGI or anything like that. Okay, so my presentation is structured into 4 parts. And the first part is trying to answer the question, could we already have AGI? The second is, how did we get to the state of AI that we already have now? Then the third part is, how does it work? And the fourth is, where does this lead us? And I just want to say that probably near the end of my presentation, I'm only going to be halfway towards in part 2, and maybe start at part 3, but that's fine because the part 3 and 4 are much shorter. So the first question is, could we already have AGI? In the description of the symposium, I read that artificial general intelligence, AGI, is a hypothetical form of AI that does not exist yet, but is likely to emerge in the not so distant future. And so I will take the provocative point of view that in between the time that this description was written and now we actually have AGI which has emerged. I think it was written maybe a month ago, and in the meanwhile there is this article that was published in Nature, and this is exactly what the author of this paper published 8 days ago in Nature say. So based on the evidence, they say we already have AGI. And this may seem outrageous to you, but let's look at why this may be the case. And I'm going to say this probably a few times. I'm going to take a completely operational definition of AI, and there's really, really good reasons to do that. So we're not going to go into philosophical questions that's like for other people to do. We purely look at what capabilities and what things can do. So let's look at some chart evidence. So we all know LLMs, so large language models, Gen AI, ChatGPT, whatever you want to call it, burst onto the scene a few years ago. I think it was 2020 when ChatGPT was released and students were asking all kinds of questions. So it's been about 6 years now since we've had these models. And only in the last 2 years, so as you see in this year, it's November 2024 until about this time frame, we see that the performance of these models, such as GPT, DeepSeek, O3, Sonnet, that's Claude, Grok, etc., is getting better and better and better on a wide range of tasks, such as expert-level reasoning, coding, that's programming, abstract reasoning, and text-based video games. So what you're seeing is all kinds of tests that the people who make these models use to train their models, but also to test their performance on. And whereas we were on an average for 10% on all of these tasks taken together when GPT 4.0 was released in, this is probably December 2024, we have now models such as Opus 4.5, that's Claude by Anthropic, and GPT 5.2, that is OpenAI, that score now an average of 50% on these benchmarks. And you might say, yeah, well, is that impressive, like 50%? I mean, I'm sure really good humans could do better, but I think that's part of the point here. So these are a lot of different things, and I'm pretty sure that most of us in this room, including myself, would not score very highly at these tasks. Let's look at other tasks. These are vision capabilities, and so it's very often argued that machine learning, LLM models lack the ability to do mental visualization, spatial navigation, are able to understand the physics of the world, are able to do embodied reasoning. But there, again, we see that the performance of these tasks over the last 2 years has been steadily rising, and we are here at this point. So the claim that, you know, we're really at this point where we might have AGI emerging, or we might already have it, is not completely far-fetched. And there's another chart I want to show you, and I think this is a really, really important thing, because these are tests, benchmark tests as we call them, that we give to all AI models to see how they are doing. But there's another really important thing that we try to let AI do, and that's to act responsibly. And there's also a bunch of tests for that, and this is another chart. This is the AI risk index. And this is the amount of jailbreaks that you can do. So meaning that you can give specific instructions to the AI so that it doesn't respect the instructions that it came with. And it lets you understand how to build a bomb, for instance. Or it gives you dangerous psychological advice. Or it is racist or shows discriminatory behavior, all kinds of these things. And on this, lower is better, and we see also a massive increase in this decrease in this risk index. So models are getting better, better, and better also at doing what their creators are making them for. So, all right. So I want to make you understand also, or I want to try to understand why having an operational definition of AGI or of intelligence in general is really important. So these tests are benchmarks, right? So this is just a score on a particular test. They're not deep examinations into whether this is really thinking or whether this is really consciousness or whether there's any intention behind all of these things, right? So it's nothing about that. Or how it's being done. I mean, the test could care less about the which model is doing it or how it is built. It's just that all of these behaviors, if we would look at them and take them at face value, they're all behaviors that require a certain degree of intelligence if humans would do them. in that sense, they are like the Turing test, right? And the Turing test is something that you may have heard of. It's also called the imitation game. And there's also now the claim, I think this is a paper which has actually not been published in peer review, but an important paper basically that claims that, I think this is April 2025, large language models passed the Turing test. So I'd like to go a little bit deeper into that and see what Turing had to say about this. And this is published in 1950 in the journal Mind, which is a quarterly review of psychology and philosophy, in an article called Computing, Machinery, and Intelligence. And students of my Introduction to AI 1 course know this article very well, because in the first year in cognitive science and AI, we talk about this article at length, and you need to study it. And we discuss it in class. It's always a lot of fun. And in the first paragraph of this article goes like this. I'm like condensing it. What's in italics is literal. Turing says, I propose to consider the question, can machines think? And then, next, this should begin with definitions of the meaning of the term machines and think, and then an elaborate explanation which basically says I'm not going to do that because I'm not a masochist and I actually want to get something done. So I need an operational definition of intelligence, because if I need to define machine and think, we're getting nowhere. And he says, I shall replace the question by another which is closely related to it and is expressed in relatively unambiguous word. And it's not a question, another question, it's actually a game, and it's called the imitation game. And the imitation game goes something like this. You have a judge, and the judge has 5 minutes to interrogate each contestant in the game, and then has to decide which one is the human. By the way, this is all text, so that you don't have any way of saying like, hey, this is a human because they smell human, right? Or something else. And the judge can ask questions to contestant A and contestant B. There's 2 of them. In our case, contestant A is a machine, but the judge doesn't know this, and contestant B is a human, but the judge doesn't know this. The machine must try to deceive the judge, and the other human contestant must be truthful, so they must answer truthfully. And the judge has 5 minutes to ask questions to understand which one of these is human. They can ask questions such as, what's your favorite season? And then the computer can answer autumn, I think. I love the colors and the crisp air. What's 17 times 23? And the machine needs to deceive, right? So even if it knows it's 391, it can say 391, well, wait, let me think, 391, yes, that's right. So based on these questions, you need to make a difference. Anybody worked with an LLM recently? And understand that when you ask these questions, you get very reasonable answers, that even, especially if you ask the model to give human-like responses. So it's not far-fetched that this actually works, and with some tricks that we can get to that level that machines pass the Turing test. So Turing's prediction for the future in 1950 was that I believe that in about 50 years, the year 2000, it will be possible to program computers to make them play the imitation game so well that an average interrogator will not have more than 70% chance of making the right identification after 5 minutes of questioning. The right identification means picking out the human. And he also says, by the way, the original question, can machines think, I believe to be too meaningless to deserve a discussion. So what this means is we must look at operational things to look at what's intelligent. It doesn't really matter what it's doing. So, pop quiz? You didn't expect this. So, all right, let's see if you followed until now. Which of the following statements is correct? Students will recognize this as typical from Introduction to AI 1 exam. When considering the question, can machines think? Turing starts by providing clear definitions of machine and think. Yes? No? So, answer no, not at all. Operational definitions. Turing believed that there was overwhelming statistical evidence for telepathy. Yes? No? He does, in that article. So it's really interesting. It's really weird, but he says that there's overwhelming statistical evidence for telepathy. You don't know this, but the students get this wrong on the exam all the time. And it's an open book exam, so they can look it up. In the imitation game, all participants need to be truthful, correct? not correct? No. So one must deceive. Only the human needs to be truthful. The Turing test is no longer relevant. You can make your own mind up about this. All right. So let's get back to that article, Does AI Already Have Human-Level Intelligence, from October 2nd of this year. The evidence is clear. All right. It also takes this position that if we look at behavior, we have AGI, right? It also, like Turing's paper, and this is interesting, goes through all kinds of objections that people might have to this thing. The Turing paper is famous for its long list of objections which it talks through. And one of the objections is, but it doesn't do this well, or it doesn't do that well. And Gary Marcus, whose blog you should follow, famous AI critic, says all kinds of really, really interesting things of AI, is really good at this. And pointing out things like, but the model doesn't do this, and it fails at this, and it fails at this. But that's not what general intelligence is. General intelligence does not mean that you can't fail at any task. So it's not about perfection, right? It's also not about universality. It also doesn't mean like it's everything that you need to do very well, or you need to excel at all tasks. No, that's not what general intelligence is. It's also not human similarity. It doesn't mean that you need to like humans do it, because that would be stupid in some cases. And it's also not super intelligence. It doesn't mean that we're talking about this wild future in which AI takes over the world. All of that is not what you would understand as super intelligence. And by the way, in terms of artificial intelligence, I think it's Amos Tversky who said, my colleagues study artificial intelligence, I study natural stupidity, because he studies human biases in human thought and thinking processes. Well, good. They also claim that there is a cascade of evidence that brings us closer and closer to being able to say that we have AGI. And there are different levels, right? Level 1, they say Turing test level, is just having basic conversations. Okay, this is possible. I mean, you can have basic conversations with a large language model. And we're getting to also level 2, where you have expert level, for instance, gold medal performance at things like the Olympiad, even on questions that the model didn't see before. Yes, it's trained to perform really well on these things. Debugging complex code. These are all things that we currently have. And then the third one is superhuman level. We don't have that yet. We don't have revolutionary scientific discoveries by these models independently. And consistent superiority over leading human expert. But AI assists in a lot of revolutionary scientific discovery, like AlphaFold, for instance. All right, now that we have that, let's go to the second part. Going to be slightly shorter. How did we get here? And I'm not going to explain into detail the mechanics, but I want to say that there are, if you take a bird's eye view, without going into details about how current or past AI models work, we can see 3 important factors at work. It's not about how the models work. And the first one is compute, the second one is data, and the third one is number of parameters. All right, so I have a bunch of charts here. The first chart shows the amount of flop, those are floating point operations, that's an essential part of how the computer works, that you need to train a model. And so typically these are neural network models, and this is the amount of floating point operation. Each time you go up on the scale, there is 100 times more compute. And so we're starting from 1950 until now, 2026. And you see that there is a dramatic increase. So every 5 years, we have 100 times more compute over this entire period of time. And here, since 2010, we have about 1,000 times more compute every 5 years. So the capabilities of the hardware that you are able to run those models on has increased dramatically. That's the first factor. Then the second one is data. And this is really important for these general models that we're talking about that drive things like ChatGPT, is that they consume an insane amount of data. And again, this is a logarithmic scale. It's slightly different, but you have, again, 100 time increase every 10 years or so, right? And since 2010, the amount of data that these models consume has also increased dramatically. They basically consume anything that's ever written. So it's an insane amount of data that goes into those models. The third one is more parameters. And more parameters means, this is especially important for neural networks, it is basically relates to the amount of information the model can learn or store. And here, again, we are starting from almost nothing. These are about like 10 parameters, 10 to 100 parameters, to now a few trillion parameters. So this increase also drives this. So 3 factors: compute, data, and parameters. And then there's a fourth one, which I didn't talk about, but which is also important, and this is money. And so the amount of money that is now allocated to the development of AI models also has dramatically increased, and this goes on again and again and again. So where this is times 100, this is times 100, and this is times 100. And we are now, these frontier labs are allocating hundreds of millions of dollars to training one of these single models. All right. Then, how does it work? And I think that's what I'm invited to do. I'm not going to do it in much detail, but I'm because it would take a few courses to do this in any important way. But I'll try to get the big picture. And I've chosen some events. This is like a very personal timeline of AI development over the years, which I used to illustrate, try to illustrate a few points. In 1967, we have a chess program called MacHack6, which is the first chess program with an ELO rating. It has an ELO rating of 1,200 something. For people who play chess, it basically beats everybody in this room. So it definitely beats me. So I think I'm at like 800 or something if I play on chess.com. And it uses a very simple method developed in 1928 by John van Neumann called Minimax, and it has really few data. So with very, very little compute and very little data, in 1967 you can already do something that is considered narrow AI and is really, really good at this task. Then we skip 30 years because nothing has happened in between. 1997, Deep Blue defeats Kasparov. Same algorithm with a few computational tricks and massive amounts of computers, but basically same approach. Then in 2001, another milestone, different approach, neural networks and classical machine learning, Viola-Jones real-time face detection. That's basically an algorithm that is able to detect real-time whether there is a face in the picture or not. And then 2012, we entered the deep learning era. AlexNet is a program that wins the ImageNet challenge, which is about recognizing and classifying images. Then 2016, AlphaGo is a new approach based on deep learning that not only solves chess, but also the more difficult game of Go and defeats the world champion in Go, who retires depressed, or at least that's the what the movie says. And then it needs a lot of data. It stores a lot of games. But a few years later, the same lab, DeepMind, programs AlphaZero that basically teaches itself to play chess and Go and some other games, and reaches in a few days superhuman performance through deep reinforcement learning. So we're talking about a lot of things that happen through the development of neural networks. They need a lot of compute. They need some need a lot of data and some don't. Finally, in 2017, that's where the history stops. We have a paper called Attention is All You Need, which introduces a transformer architecture on machine translation and basically shows, hey, this task of machine translation, translating from one language into the other, basically, for practical purposes solved. This was around of the time that Google Translate and other approaches started to work, and you could see the difference. So this transformer architecture becomes really, really important. And then we see in 2019, GPT-2, which is basically the same transformer architecture, is not a model that's built to translate, but just to predict the next word in the text. And so if you ask it something, it's going to try to predict what comes after, typically a question that's been asked. And it shows something that's really important, zero-shot learning. You don't need to train it to actually do these things. It actually says like, yeah, this is a natural course of thing. You ask a question, after that, you know, from all of the parameters I have, from all of the data I have, I learned that afterwards there is an answer. And this becomes really important as a foundation for the models that we have today. It uses a lot of compute. This is 1.5, I don't know how much, this is probably a few petaflops or something, uses 11 billion tokens, and it was 1.5 billion parameters. Then we have ChatGPT, that's 2022, apparently, or that's what I wrote down. It has this transformer, but adds something else to it. So it's another technique, reinforcement learning through human feedback. So there's people who rate these responses and then say like, yeah, you did well, or you didn't, you did badly. This is a good response, this is not. And the model can adjust based on that. 300 billion tokens. I think, what is this? 1 million times more compute. A lot more parameters. GPT-4, that's 2023. Multimodal transformer plus reinforcement learning means it's not just language, but also vision that goes into that. Again, more data, more parameters. This is the model I'm using today, Claude Opus 4.6, multimodal transformer and constitutional AI and reinforcement learning through human feedback and extended thinking and tool use. So we're not talking about the same thing anymore. We're not just talking about language models. We've added a lot of things to it in the last years. So I don't know how much time I have, but I think that this point is really important. We are not talking about just one technique, this transformer anymore that learns basically to predict language and does it really well. There's a lot of things added to it when you are interacting with current AI models. So I'm looking at a typical training pipeline. By the way, I'm going to be completely transparent to this. I asked Claude 4.6 to do this yesterday. So we have, with some, back and forth between me and it. Transformer architecture, that's the basis. It's a neural network designed with self-attention. You can read the papers if you want. And what this does is you have some basic capabilities. You process sequences in parallel, and you have long-range dependencies. And that gives you the ability to put input text, and then it generates something that's likely to come next. Then there is pre-training. That's the data that you put in. The amount of data and the way it's put in and the way it's cleaned has massively improved. And this gives broad knowledge of language, grammar, facts, world models, in-context learning, emergent reasoning ability. Then, other thing, on top of that, supervised fine-tuning. So this is on curated prompt response pairs. So it's not with human feedback, but basically sets of data where you basically say, this is a question, this is a good answer. So you feed that into the model, it learns to do that a little bit better. Allows it to learn instructions, converse in turns, so back and forth, use desired response formats. Then we have preference alignment. That's just basically the last years. Something called constitutional AI is used, for instance, by Anthropic for this. And that's basically the model giving itself feedback. So it's one AI training another AI and saying like, here is my output, can you critique it for me? Can you make it better? And it helps the model show helpful, harmless, and honest behavior, give appropriate refusals, reduce toxicity, etc. Then there's the next one, reinforcement learning for reasoning, where you give it really hard problems and you try it to make it better based to do these really hard problems. And it gives capabilities such as chain of thought reasoning, extended thinking, self-correction, improved accuracy on complex multi-step tasks. Okay, that's a lot. And I'm getting to the last part, which is not that much, because I don't know what the future will bring. But I think that many of us have underestimated the advances that we have in AI. So the next question is, so I'll skip this one. Where will this lead us? And I can find articles like I discussed with my students this morning that this will lead us to doom. And we will all become dependent on AI, and humanity will perish, and it will vanish. But again, yeah, what do we have, right? So we need to work with what we have. I'm not talking about robotics and what may happen in there. There is a report, which maybe you've heard of, which is called AI 2027, which was made in 2025, where a bunch of AI safety researchers write a narrative future for AI, and that basically says that we will have AGI in 2027. And it's kind of a mixture of data, scaling, so things becoming better and better, and you could say intuition. It's interesting to read about. So what can you do and when will these things happen? That report was criticized. Nonetheless, I think it's interesting to go through these things, and also, if you read it before, to go back to it and say like, okay, so what about this was correct and what wasn't? The same researchers now have a new timeline based on more data and more milestones, and so this becomes really interesting about the future of AI, which is called the AI Futures Model, and you see some predictions about how things will evolve. AC, for instance, that is an automatic coder. SAR, I think, is artificial research or something. And here we have ASI, which is not AGI, not artificial general intelligence, but artificial super intelligence. So lots of interesting details that you can go into, but this is basically what we're looking towards is improvements of some kind. And we're going to see these models improving for quite a bit of time, being able to do more and more tasks. Whether this will lead us to superintelligence, I don't know. But it's definitely going to lead us to a lot of fun things in the future.
Thank you, Professor. I suppose that even that this presentation gave each of us quite some insight into technicalities of AI and AGI to be. Now I would like to invite Professor. Oh no, actually we got the time for one question. So if there is at least one burning question in that room, there is one. Yes.
What is superintelligence?
I think that Nathan will answer that question. We have time for one more question.
Thank you.
You say that the artificial general intelligence is not like perfect and everything, but to me it seems like people expect that. They expect human similarity, they expect perfection.
Yeah.
So.
And I think it's important to make these differences. I think if you expect superintelligence, yeah, okay, you expect superior intelligence, but the operational definition of AGI that everybody agreed to, you know, that everybody said, yeah, never going to work. They're never going to pass the Turing test. Yeah, okay, now it's there. And then you need to accept that, you know, some milestones have been reached. I don't say anything about whether these things reason, whether they think, whether they have consciousness, whether they have intentionality, but purely based on operational output, yeah, you have some behavior.
Okay, so you would say that then already we have general intelligence, in a sense, in the operational sense.
I think in the operational sense, there's a very good case to say that, yes.
Okay.
Yeah.
Thank you, Professor. Let's give a professor a small applause. And now I would like to introduce to us Professor Nathan Wildman, whom, excluding being the most friendly lecturer in the department, also focuses on researching philosophy, logic, and philosophy of technology. And he will give us an insight into what actually intelligence is, because since we aim to create artificial general intelligence, we need to also know what natural, let's call it that way, intelligence is, and this is what Professor Wildman will help us with. Let's also welcome him with warm applause.
Cool. Everybody hear me okay? Lovely to see you all. So unlike Emmanuel, I will stick to the brief. Importantly, what I'm going to try to do at least a little bit is I want to fill in some of the concepts and definitions that Emmanuel was using, kind of presupposing. If you want, I am the masochist that Turing didn't want to be, or at least partially. So what I want to try and do is start off by talking a little bit about this general idea of intelligence. So in particular, I want to think about this idea of being smarter. Because remember, the big question is, what happens when these machines outsmart us? They're smarter than us. So what the hell does it mean to say they're smarter? I want to talk about that. And then I want to end this section, by thinking about one of the upshots that you might be tempted to go with if the machines are smarter. And I'm going to call it the argument for epistocracy. Do people know what epistocracy is? So we've got 1. 2. Okay, cool, good. Then it's helpful that I'll define it as well. So I'm going to talk about this argument for epistocracy. And then I'm going to pivot hard to some real contemporary cutting-edge philosophy to tell you a little bit about a philosophical precedent that will help us think about the argument for epistocracy and why it probably doesn't work. And then I want to talk about a couple models we might have for how we can engage with what I'm going to call SAGIs, right? These super intelligent general AIs. And in particular, I'm going to sketch one model that I think has to be the right one, even if we think that these machines are infinitely smarter than us. And finally, I'm going to come back and step a little back from this kind of pie in the sky thinking about super intelligences to think about the kinds of ones that we actually deal with in our day-to-day lives and how then we should deal with them. So that's the plan. I forgot to start my timer, which is just dandy. So, all right, let's talk about smarter. What does it mean to be smarter then? Right. Well, what do we mean when we say something is intelligent? First thing I want to say is this is a buzzword. This is something that there's so many different definitions and characterizations of, it is almost useless to try and characterize. That said, here's a rough and ready characterization. We can say that it's the capacity to exercise relevant agency, a word that's going to come back, that is, select and execute actions to further situational goals under conditions of uncertainty. So it's not just sort of, hey, definitely going to happen or definitely do this, then this happens, with limited energy, time, and computational resources. Now note this notion of computational resources could be flops, it could be meat work inside your brain, right? Very loose notion of computational here. Now, this is a rough and ready characterization of intelligence, but of course, there's different ways to kind of precify what we're talking about here. And one typical version of this is the distinction, in fact, Emmanuel talked about it implicitly already, between what we might call narrow and general intelligence. Narrow is basically only really able to operate in restricted environments to perform predefined tasks. So they might be really good at very specific types of actions, but if you put it in a different sort of context, it's not going to do nothing. Right? So contrast that with this notion of general intelligence, where we have something that's going to be able to learn inductively, right, build off experience, and it will be able to adapt task-specific skills to novel contexts. So it might be really, really good at, say, designing sewer systems, right? And that's all it can do. Cool, wonderful little narrow system. Or it might be able to take that and extend it to other things, like, say, designing air conditioning systems, designing hallways, designing pathways for people to move around buildings. You can start to see how this spreads out. Now, I think this narrow and general distinction is still a little bit too narrow, forgive the pun. In particular, I think that what it doesn't do is incorporate two different axes that we really need to think about when we're trying to characterize intelligence. So we can start to kind of come at the two axes by thinking about what I'll call ill-defined problems. So these are problems, situations that you need to resolve where the terms, the initial or final states, or the general context are vague, underdetermined, potentially ill-defined. You want to solve the problem. What does solving the problem look like? What even is the problem? What situation are you starting in? This is the kind of thing that we, as human beings wandering around in the world, frequently run into. So solving ill-defined problems requires an ability to learn, and most importantly, to generalize, to abstract, to be able to apply some skill or a bit of knowledge from one area into another one, often via something like analogical thinking. You see an analogy, you see how you can use the skill from over here in this other situation. So what this actually gives you is a different kind of way to think about this narrow general. It gives you a slightly more gradations here. So we might contrast what we'll call local, broad, and extreme generalizations. The local one is just where you can apply skills to new but familiar situations, new tokens of the same type. So again, this is kind of like the narrow, but a little bit different characterization. And then you have what we might call the broad, and this is actually going to be the kind of middle point in my sliding scale here. This broad generalization ability is you can adapt to what's called unknown unknowns, right, across a broad range of situations. Not everyone, maybe just a very narrow one. The kind of joke example I gave earlier where this sewer designing system can extend itself out to thinking about, say, people moving around hallways. That might be something closer to the broad one. But if you give it, say, hey, how do you solve a chess problem? It's probably not going to do so well. And then finally, you have this really extreme generalization. And this is where you're able to adapt to an unknown range of unknown situations. Right? And I leave it very, very vague here because I want that to keep going. Right? I want that to be as extreme and broad as possible. So this is one kind of axis we might think of. Very limited range of applications, and then steadily widening out to potentially any that you run into. Now there's another axis that we might invoke here that sometimes gets passed around in philosophy of mind as being grounded or ungrounded. And the way you can think about this is, okay, here, when we think about meatbags like us, our cognition is inherently rooted in bodily stuff, right? That is, it's tied up in our perceptions, in our moving around capabilities, how our meatbag senses feed into it, right? And how we interact with our environment. It's not just something that's purely intellectual, purely abstract. Contrast that sort of grounded existence, grounded cognition, with purely abstract thinking, purely abstract reasoning, decoupled from any kind of sensory modalities, or as many of them as we can, right? And not really tied up with any kind of bodily engagement with an environment. Right? So the thought is, right, when we're thinking about a grounded cognition or this grounded notion of the mind, the world isn't merely a set of facts, but it's something that's, in a sense, subjectively meaningful. So this is going to be bound up with these notions of intentionality and things like this. I'm leaving this vague because, frankly, this concept is pretty vague, but I hope we can start to at least get a little grip on what this distinction is. Now, it's tempting to think of this as just binary, right? You're either fully on or fully off. You're fully grounded or fully ungrounded, and that's a mistake. This is also going to be graded as well. So when you tie these two together, you get a very beautiful graph here, right? where you've got this sort of local generalization on one end, going to the extreme on the other, and you have completely detached, at the very tippy top, back down to fully embodied cognition. And of course, when we're thinking about where to place ourselves, right, we might be tempted to go way down here, but that's just not true. Right? Most of us aren't all the way down in the corner. We're probably somewhere in there. Right? Pretty good at generalizing, maybe not entirely across the board, pretty grounded, but not always. Depends on the circumstance. Where do we want to put AI? Well, different ones might get different locations. It also depends on the circumstances, the kind of questions we're asking it. That's perfectly fine. But this is giving you, I hope, a way to start to approach questions about intelligence. What would it mean to be smarter than? Well, one way to characterize it is to be a little bit better at this generalization, or to just be, if we're thinking about it, in a very particular context and just really good at that one particular context. Okay, so that's all this background on intelligence. Now let's come back to the question. I couldn't remember who it was that asked. I didn't get to look. Nice. So what the hell is superintelligence? All right, so let's talk about SAGIs. Superintelligence are these AGIs that are super duper. They're on steroids. So actually, following an article from Good in 1965, he says, let's call a superintelligence as a machine that can far surpass all the intellectual activities of any person, however clever they happen to be. So they're AGIs that are better than us. They're better knowers. They're smarter than the smartest human being ever was and ever will be. They're real damn good. Right? So, okay. You might think about this in the way that I was talking about it as they are on the very far right-hand side of my extreme generalizability scale. Are they grounded or ungrounded? I'm not too concerned, at least for what I want to do from here on out. I'm happy to set aside the grounded-ungrounded spectrum for now. So could there be such a thing as a SAGI? I'm not sure. I'm going to grant it for the sake of what I want to say. Right? I think, and this is more Emmanuel's ballpark than mine, but I suspect if there is going to be such a thing, it's going to have fundamentally different architecture and training than what we have now, but that's beyond my pay grade. Let's just grant that there are going to be such things. Will a SAGI, if there is such a thing, think like us? Well, it really depends on what we mean by like us. Let's hope to God it doesn't solve problems in the same inefficient way that we do. Right? But what I'm really interested in here is, will these things have the same broad concepts as us? Will they carve the world up in the same basic way? Will they have the same normative notions, shoulds and oughts? Right? Will they have the same kind of social and political approaches that we do? Why do I care about that? Because of the bottom question. Will we be able to communicate with them? If they're radically different conceptual machines, it's really unclear if we'll be able to communicate, and then we're in some very interesting waters. So let's just assume that it'll be sufficiently like us that we can talk to them. So we're granting that they're possible, we're granting we can talk to them, that they carve out the world at least close enough to us that we can do stuff with them. Here's the fun question. Suppose we have one, or a bunch. Should we let them tell us what to do? That is, should we just accept what they tell us and do it? Right? Let them restructure society, let them govern. I think there's a really tempting argument to say yes. So here's the argument, quick and dirty. So there are true procedurally independent normative standards by which political, social, personal activities can be evaluated. There's a good or bad way for things to be evaluated. Right? Okay? Some individuals know more about these normative standards and associated facts than others. Some are better at making these kinds of judgments. This superior knowledge justifies those individuals having authority over those with lesser knowledge. Right? Why? Well, look, they know more. They know how to do it better. So, of course, they're the experts. They should be in charge. Therefore, knowledge is justification for power. They're better. They should be in charge. And of course, just to tack it on, a saggy would be the ultimate knower. It'd be the best that ever was and then some. So, of course we should surrender our agency to saggies, right? Okay, so this is my argument for epistocracy. Now, how many of you are happy with the argument for epistocracy? Emmanuel's already sold himself out. I, for one, welcome our robot overlords. No. So, okay, here. I think everybody should be worried about this argument. I think it's a bad argument. And I want to talk to you again about some cutting-edge philosophy to show why it's a bad argument. So I'm going to turn to a philosophical precedent. Again, this is the most cutting-edge, best philosophy we have. Plato's Republic came out 2,500 years ago, right? Thereabouts. So, everybody familiar with Plato's Republic? Have you heard of it at least? Beautiful. So, Plato's Republic is a sort of Socratic dialogue, very generous calling it a dialogue, right? That is effectively an extended argument for epistocracy. It's a really long version of that argument I just gave you. So it's effectively about building the perfect city. And according to Plato, who was a philosopher, the perfect city would be ruled by philosopher kings. I like this as a philosopher. Of course, I accept no responsibility, so that's fine. In particular, he thinks that the reason philosophers should be kings is because we're the wisest. We know the most. He wants an epistocracy, ruled by knowers, ruled by the learned. Right? Now note there's various forms epistocracy can take. You can have it be a version of democracy, where smarter people's votes count for more. You can have it one where only the smarties get to have votes. I'm not really concerned about what exactly method we want. I'm just going to target very broadly this concept. So Socrates, who's Plato's mouthpiece throughout the Republic, argues that the perfect city has to be an epistocracy. Right? Why? Well, there's Platonic underpinnings here, right? Plato thinks that true knowledge will all come back to knowledge of the good. Note with a capital G. This is a form that one accesses. And it's then reflected in every single kind of practical decision and instance you would want to think about. Right? And the better grasp of the good will then mean better grasp of things like justice, fairness, moral correctness, appropriate social interactions, things like this. Since, according to Plato, the smarties, the philosopher kings, have the best grasp of the good, of course they should be in charge, because they will have the best grasp of justice, fairness, etc., etc., etc. Note the parallels with the argument I gave you earlier. Now here's the interesting thing. After Socrates kind of pitches the argument, one of his interlocutors, I believe it's Glaucon, but I don't remember exactly, he says, I don't think anybody's going to actually buy this. And Socrates says, oh, that's cool. Here's what we're going to do. We're going to tell them a noble lie. And the noble lie is going to make it such that everyone will actually buy into this society. So what's the noble lie? Right? It's that every person has an essential inherent nature that determines where in the city's hierarchy they rank. That is, there's some kind of intrinsic fixed nature that you have, which means you're never going to move up or down. You're always going to be super smart if you're smart. You're always going to be real dumb if you're dumb. Right? Or to put it better, talks about the myth of the metals, so that there's some whose nature is gold. And these are, of course, the ones who have the power to actually structure things, the power to actually make laws, to guide the city, because they have proper knowledge of the good. Then you have the silver. These are the auxiliaries, the police force, the military, right? They have some knowledge of the good, but not enough to really be gold. And then finally, you have the producing classes, who are made of brass and iron. And they're barred from participating in politics because they just don't have enough knowledge. One thing that's nice is they do throw a little bone, right? Class isn't inherited. You could be a child of two brass and iron people and then turn out to be gold. But of course, once you've been classified, there is no moving. You're locked in. I find this utterly repugnant. Utterly repugnant. I think there's many, many, many reasons to reject this picture. The one I want to focus on has to do with removal of agency from nearly all citizens. So when I say agency, what I mean is the ability to make your own informed, uncoerced decisions. I think agency is a fundamental part of what it is to be human. I think we all have a fundamental right to agency. And the problem that I see with the Republic is that non-gold citizens are taken to be so dumb, or at least not smart enough, that they could not make properly informed decisions. So they must be coerced. They must be forced because they're not capable to make their own decisions. And I think this is fundamentally wrong because of this right to agency, right to autonomy. So that's my little philosophical segue. Please.
So like, we're making the assumption that actually there is this good, okay? And like,
Yeah.
a saggy or a philosopher can actually tap into it.
Yeah.
You're basically saying that to debunk the epistocracy argument, we need to say that agency is more important than good.
No, I don't think so. So I think that whatever we want to say about grasp of the good, right, you cannot force someone into behaving a certain kind of way. You cannot coerce them into it. The good would not be good anymore if it's being forced upon you, if it's dictated unto you, if you are required to behave well. Right?
Yeah, okay, but like, yeah, isn't it the same thing then?
No. So importantly, what I'm saying is, right, it's not that the general good, the greater good, would be undermined. It's that it's infinitely better if the way that you get it is to convince people to come to it, rather than to just beat them into it. That's what I want to get to, right? So it's not giving up on the notion of good. It's not saying that agency is more important. It's saying that goodness reached non-agentially, right? It's not good anymore. That's the claim I want to make. Right? So coming back to the saggy, we already kind of see where this is going to go, right? Remember the argument from epistocracy I gave you. Where am I going to get off the boat? Right there. Right? Superior knowledge doesn't give you the authority over others. Right? Shouldn't. That's what I want to say. So everything then follows from that is also just going to be rejected. So, okay, setting that in place, how then should we think about the relationship between these saggies and humans and us? Well, this is going to be very quick. I think there are a few models that we might think about saggy human relationships. One of them that I include, just for sake of argument, is you might think that the relationship here should be one of owner to object. And I say object here, right? Where the saggy is the owner and we are the mere toys. Right? It's so smart and it knows everything so much better than us, then we have no rights. We're basically just some object it can do with us as we will. Another way we might think about this relationship is a kind of adult-child. And what I really want to lean into there is that we would be the children. And we're the children because we are so undeveloped in our epistemic grasp of things that we cannot be trusted to make informed, uncoerced decisions. The failure is going to be in the first adjective there. I think the best model is one that's very similar to a doctor and a patient, particularly an adult patient. So here's something that's fundamental to medical ethics. Doctors don't decide treatment for you. They advise treatment, and then you can say yes or no. So the thought here is that's the way these should be done. The SAGI can be treated like a general expert. It might be better informed, but the decisions about what to do still need to be left to individuals, to humans. And I'm thinking about this at the individual level. We could do something similar at society level as well. Right? What I really want to say is if you followed me up so far, if you think that objection to the epistocracy argument's good, then pretty obviously you shouldn't like those first two models. It's going to have to be something like this. Okay, so what have I done so far? Talked about the superintelligence and tried to kind of articulate what I think we should think about if these things really do outsmart us. Right? Because in the kind of fancy scenario I'm playing with, they're super duper smart. So of course they're going to be amazing. And of course we'll run into this question. But I want to come back to reality for a second and think about a kind of restriction. So everything I was just talking about is basically strung on this sort of omnipotent or nigh omnipotent, omniscient superintelligence. But I think everything I've said also applies to much more restricted general intelligences, or even local ones. Right? In the limited context where an AI is going to be a great knower, an expert knower, I still think we shouldn't surrender our context-restricted agencies to these tools for the exact same reasons. Right? Again, the core thought is doctors advise their patients. They do not make the decision for them. So even in these limited contexts, the AI should be an expert, should provide advice, but it should not make the decision for you. Generally, I think that if you value your agency, which is an if, then don't surrender even context-specific agency, because that's giving away something that's deeply, deeply important. Okay, so to wrap up, I started off by saying, look, intelligence is a messy term, but I've tried to give you this sort of two-axis approach where we have the local to the generalizations, and we have the grounded to the ungrounded. I tried to then go through this epistocracy argument to show you that it turns on rejecting something like a right to agency, and have argued that more knowledge does not entail the right to more power, even if it's an infinite more knowledge. Right? I then tried to very quickly push for this sort of doctor-patient model as a way to think about the relationship between humans and these superintelligences, and then finally very quickly gestured at this thought, right, that the arguments I've given here applies not just in the pie-in-the-sky superintelligence case, but also in the much more restricted, localized versions of AI. So cool. Thanks for listening, guys.
So, thank you, Professor. I think this part of Symposium answered many questions that many of us had, because it didn't focus necessarily on technical aspects, but rather of, let's say, humanity side on that. And with that, I would like to invite our third speaker, means Étienne Augé, who came here from Rotterdam. So I think that's a good way to welcome him with even bigger applause. Étienne specializes in science fiction, media culture, and imagination of future technologies. And that means his research explores how speculative stories shape public understanding of science, innovation, and new upcoming technologies. So rather than treating those as mere fantasies, he approaches it from the rather cultural way. So how people think those will predict future and how things will develop because of technologies described in cultural text.
Thank you. Thank you very much. It's my first time in Tilburg. I'm very happy. I have a beautiful campus. When Tilburg actually invited me, they say we need a third white guy with a beard and not too many hair. So I say I'm your dude. Indeed, I'm coming from Erasmus University. I have a talk for you today and also a bunch of questions. Since we speak about artificial intelligence, I have a question for you, a fundamental question that also can be addressed to the other speakers, which is, are we really that smart? In a sense that sometimes I do doubt it, okay? This is Donald Trump, the current president of the United States, and maybe the next one, from what I understand. And what I would like to speak to you today is about a few things that we do at Erasmus University. I teach many things, including future studies. Future studies is basically a discipline where we try to understand what the future could be or what the future should be. And indeed, we are very much inspired by President Trump, and we want to make the future great again. And for this, one of the tools we have is a tool to help imagination, proactive imagination. And maybe you guessed it, it's science fiction. I like that gift very much. I use it all the time. I speak about science fiction. You see the little rockets like this, wonderful. And the idea of science fiction is basically it's something that is quite fascinating. It appears at the end of the 19th century in both, at pretty much the same time, France and Great Britain, at the time colonial empires. And the idea is that for the first time, it's about saving humankind with reason and technology as opposed to philosophy or religion, to sort of have some kind of capacity to control your destiny. Now, many definitions can be given about science fiction. One I like very much is from Arthur C. Clarke, and maybe you heard about him because he wrote the script for one of the best science fiction films of all time, 2001: A Space Odyssey. If you haven't seen it, watch it, especially with the Pink Floyd ending. More about that later. Arthur C. Clarke is giving a great definition, especially in those post-Harry Potter time. He says fantasy, something couldn't happen, though you often only wish that it could. So you never received a letter from Hogwarts given by an owl, and it will never happen, okay? Science fiction is something that could happen, but usually you don't want it to. That's the thing about science fiction. Usually the future that is depicted is something that is quite gloomy. I like this definition by C. Clarke. And C. Clarke has worked on science fiction. Science fiction is huge. It's evolving all the time. That's also the great thing about science fiction. It's very much open. But science fiction is using a trope, an old trope in humanity, which is the idea of having robots because they're going to serve us. So we play gods, we invent robots, and then they're going to help us. The term science fiction, in science fiction, the term robots is coming from Karel Čapek from the Czech Republic, and he wrote in 1920 a play where for the first time we're introduced to the notion of robots. Before that, we call them differently, but for the first time we use robots, and that's what we're going to do. The idea of robot, again, I lived in the Czech Republic, but I can't speak Czech to save my life. Same for the Netherlands, by the way. I've been here 14 years, and I can barely pronounce gezellig. So the idea is forced labor, and if you speak about robots, you have to speak, of course, about Isaac Asimov. And Isaac Asimov is somebody that would definitely be cancelled today when it comes to his personal life, but he's a great author of science fiction. He wrote more than 500 books, not just science fiction. He also wrote about puzzles, about crosswords, about Jesus, about the Bible, many different things, 500 books, ladies and gentlemen. And Asimov defines science fiction this way. It can be defined as the branch of literature dealing with the reaction of human beings to changes in science and technology. I like the definition of Clarke better because it's also more provocative. But Isaac Asimov is someone that indeed has a huge importance when it comes to science fiction. He wrote two of the most important cycles in science fiction, Foundation and The Robot. And The Robot also is something that has been used by many departments of robotics all around the world, especially for the 4 laws of robotics. Basically, just to summarize, you have them here. I'd rather you don't read them, but listen to me. Basically, robots should not harm humans. Sounds great, but we will see that unfortunately that's not the case. Science fiction is a great way to be proactive with your imagination because it sort of defines many different futures. It's also in future studies, we have an S, it's futures studies. When it comes to robots, for instance, science fiction provides us with a lot of different kind of scenario. One of them is that maybe in the future there will be our equals in love. You probably know that today there are many, many people which rely on artificial intelligence to find companion. There's even a new AI that you can have as a necklace called Friend. Something is scary for many people and actually wonderful for others because it follows you all day long. It's listening to all your conversation. You can speak to it, and it's called Friend. It costs 149 euros if you're interested. but it's also inspired by science fiction. The great thing about today's Silicon Valley is that many people who are working in the Silicon Valley listen to science fiction. And sometimes they did not understand that it was a warning, that science fiction is there to invent and prevent and not so much to serve as some kind of guide about future dictatorships. This is one film, speaking about love, this is a great film. Stanley Kubrick was supposed to direct it. It's called Artificial Intelligence, and it's a story in the future of a family, and they have a son who's in a coma, and it's very difficult for them. And so they get a robot that doesn't look like their son, but is acting like their son. And then the son wakes up from a coma, and the family decides to abandon the robot in a forest. And you have two ways to think about it. The first one is like, well, it's just like getting rid of the fridge. You know, it's just a device. But trust me, when you watch the film, you really feel for that poor little boy who fortunately will be helped by Jude Law, who is also some kind of gigolo. Ekta score is also a different ways to look at the future. This time it's coming from Sweden. Not a lot of science fiction is coming from Sweden. A lot of furniture is coming from Sweden, but science fiction not so much. And Real Humans is what I like to recommend when you want to think really about the interaction between humans and robots, and who-bots actually in this Ekta score. The lady that you see, she's a who-bot, so she's a robot that looks like us, thinks like us, is basically just like us. And one day she arrives in a family, and the mother is not very keen on that because she looks at her, she finds her very attractive, maybe a bit too attractive for the teenage son. And indeed, the teenage son will try to seduce that who-bot. He will fail, fortunately, because the mother will actually find a better occupation for the who-bot. She will hire her in her lawyer's office. And many questions will arise. For instance, is it, well, if you hire a robot, do you have to come up with some kind of a contract? Like, should the robot be paid? And usually when I speak about that in my courses to my students, they find it absolutely preposterous. Why would you pay a robot? And so I say, well, let's go back a few hundred years ago, and should you pay the slaves which are working for you for free? It was also something preposterous. So Ekta score is something also to help us understand the kind of relationship we should have in the future with robots. Yeah, this is age restricted. I want to show you something, but YouTube said that we have to be adults here. So I'm going to check very much. No, it's not an Epstein party. So all of us were adults. So I have to warn you that according to YouTube, what we're going to watch is a bit provocative, okay? It's about love. It's actually almost about sex. So just beware, you're adults. I think you can handle it. Caliente, like Bad Bunny would say, very hot indeed, and so YouTube thinks it's too hot. Then again, it's two female robots interacting, but it seems that for the good people at YouTube, it was too much. So science fiction is offering a lot of different ways to think about the relationship between humans and robots, and another one is indeed to suggest what was mentioned before about superintelligence, the idea of more humans than humans. And of course, the film that everybody who likes science fiction has seen is called Blade Runner, so 7 different versions. I'm not going to go into all the different versions, but Blade Runner is an absolutely amazing film. Even today, if you look at it, it's just still crazy. It's inspired by a book by Philip K. Dick, who's also a fantastic writer in science fiction, but also regular fiction, I would say, called Do Androids Dream of Electric Sheep? And we are in a future, well, actually, it's kind of the past for us. It's 2019, Los Angeles, and something happened to humankind. We're not completely sure, probably some kind of nuclear war, which at the time when it was written sounded like possible. It was a bit ridiculous to think that countries will fight using nuclear weapons. We're way past this. But at the time, 2019, a war happened. All the animals are destroyed. Part of humanity went to live in outside world. And this company called the Tyrell Corporation, there's always an evil company in pretty much all science fiction, especially cyberpunk. The Tyrell Corporation is creating replicants, they call replicants, Nexus 6, which look exactly like us. Actually, they're faster, they're stronger, they're smarter, they're everything better than us, except that they can live only for a few years. And Blade Runner is about this idea of more human than human. That's also the motto of the Tyrell Corporation. And Blade Runner stands for Blade Runner is someone who's some kind of private investigator whose job is to find the replicants, those who look exactly like us. It's impossible to distinguish them from us. except they cannot feel empathy. So they have a special test, and then they retire the Nexus 6. Now, some might say some people, some humans actually cannot feel empathy. For instance, psychopaths cannot feel empathy, but still, you cannot make an omelette without breaking eggs. And so at some point, the Blade Runner is going to meet Rachel, which is a wonderful play by Sean Young, and he doesn't know she's a replicant. She doesn't know she's a replicant, which is even more interesting in the sense that she grew up thinking that she was actually a human because she has memories. And so Blade Runner is about basically what makes us human. And is there that many things that distinguish us from our own creation? Now, one of the favorite scenarios, and the one that is probably the most spectacular in science fiction, especially in Hollywood, is the idea that, well, no more humans in a sense that the machines decide to get rid of us. It's something that is always very spectacular, always very fun, because in the end, at the end of the film, we know that it was just a bad dream. But it's one of the scenarios of Terminator 2, Judgment Day, so it's a franchise. I would recommend that you stopped after the second one. And I would like to show you just the beginning of Terminator 2, which is honestly a masterpiece. So Terminator 1 is the story of, in the future, somebody comes from the future in order to assassinate the future leader of a rebellion against robots. I'm going to show the beginning of Terminator 2, Judgment Day, so it's really the prologue to explain what happens, and you will not know more than before. Have a look. Why do the machines want to kill us? We're not really sure. There's a story about Skynet, so in artificial intelligence we create and then becomes extremely intelligent and realize that maybe the world would be a better place if we got eradicated. And it seems to be almost the same story. Again, it's a very common story in science fiction that in the future we'll create machines and the machines are going to turn against us. And that's also the point of the Matrix, except the Matrix, I would say, if you've seen the 4 of the Matrix but haven't seen this one, I do recommend Animatrix because it's giving us an answer about why the machines are trying to kill us. Actually, we try to kill them first. That's why. So the Animatrix is telling us the story of the Genesis, saying, well, we create the machines, and then they want a bit more rights. They want to be treated better. So again, think about the slaves. And we laugh at this because we made them, so we can do anything we want with them. And then they start to rebel, and we try to crush them, and become stronger, and so forth and so on. It's an escalade. But the Animatrix is explaining that, indeed, it will be very difficult for the two species to coexist. So one thing that is always interesting about science fiction is, like I said before, if you look at the Silicon Valley, you have a lot of those tech boys which are very much influenced by science fiction. For instance, Elon Musk keep talking about Foundation. He say Foundation by Asimov is one of the most important things. He's also mentioning a lot of different reasons why he wants to take humanity on Mars, and he's quoting a lot of science fiction. But what is, again, very important to understand about science fiction is that it's not about predicting. Science fiction never predicts, but it invents or it prevents. It's trying to warn us about possible futures. And most of the time, those futures are not very desirable. So there was a campaign started by Human Rights Watch a few years ago saying we have to be very careful about killer robots. So it was a campaign. At first, people thought it was some kind of hoax, but it's a real campaign. And Human Rights Watch is saying that we have to be very careful because right now we have a lot of artificial intelligence, especially in the army. You probably know that the budget of defense around the world are increasing, especially in Europe, and there's a lot of this money which is poured into AI trying to create the ultimate killer. And for many people, it sounds like it's a future, so we can still avoid it. But I have some bad news, unfortunately. It's something that was not really much in the news. In 2021, in Libya, for the first time ever, a drone took the initiative of killing a human being. It's not the first time a robot is killing a human being. It started already in the 60s, but it's the first time ever, 2021, that a machine decided to autonomously kill a human being, made the decision of killing a human being. So unfortunately, all the laws of Asimov today are obsolete, in a sense that Asimov said, well, in the hardware of robots, we should make sure that we have those 4 laws, making sure that robots do not attack us, do not try to eradicate us from the world. We see now that, unfortunately, his predictions are not going according to plan. And so the robots today are out there to kill us. Is it the end of humankind? I really like to end usually my talks on something a bit more positive, but today I'm not that positive. And maybe the end of humankind is probably not such a bad idea. Thank you so much for your time. My presentation is over. Thank you.
Are there any questions to Étienne before we move to discussion session? No questions?
You say that science fiction is not predictions, but you also say that Asimov was making prediction in his I, Robot. So
and he was always wrong. If you look at everything, I haven't read everything science fiction, unfortunately. But the thing, most people, if you look at the work of Philip K. Dick or anything, they never try to make predictions. So in 1960 exactly, Isaac Asimov made a series of 20 predictions for the New York Times, 1964, sorry. And pretty much all of them, it was about the year 2000, and all of them were wrong. But Asimov said, well, my point, so it was an article in the New York Times, very serious and everything, and he said, my point is not so much to say what the future will be, but what the future could be. So he was basically there to inspire. One of these predictions was that in the future there will be a lot of cars with robot brain. And that's indeed is a story that inspired many people, not just the founder of Tesla, but it's something that made it happen. So the prediction of science fiction, usually, it doesn't really work, but if you work, our sister university is Delft University, and sometimes we work with them, and they have a lot of great researchers and scientists. The reason we collaborate is that if you want to invent something, you have to think about it first, and that's the point of science fiction. So inventing, pretty much everything here is actually coming at some point from science fiction, like the smartphone from, let's say, Star Trek or things like this. Preventing, warning us about the possible futures, but when a science fiction author is right, usually about the prediction, most of the time it's just sheer luck, I would say.
So then the role of science fiction of preventing is actually not happening because it's inspiring people. That's what you kind of just said. I'm
going to tell you my worst joke ever. So there's this guy, and he's traveling, and he's actually coming to Tilburg. And before this, he was in Rotterdam. He's selling a spray against tigers. So you spray the place, and there won't be any tiger. And somebody say, well, does it work? He say, well, have you seen tigers in Rotterdam? No. So that's the idea of if you have something, if something doesn't happen, how do you know what prevented it? That's basically the idea. Most of the time, we don't listen to science fiction that much. Usually when I say I teach science fiction, people look at me like I'm a big nerd, geek, whatever. And it's true. But also I have to tell them, well, I also teach things like propaganda, series, whatever. But usually science fiction is not really taken seriously. I think it's going to change because of Peter Thiel, because of Elon Musk, because of all the people that grew up with science fiction. And they are making science fiction happen. But unfortunately, it's not exactly the kind of things that I believe would be positive for humanity. So, yeah, inventing and preventing, not predicting. Phew.
Okay, so now there is time for discussion session, and may I invite other speakers to take a seat? So, I think we have seen three quite unique, quite interesting perspectives on AGI or SAI, as we found out. Those are quite different, as well as how in future, how in past those things were seen in multiple books and movies, which gives us now quite unique perspective on those. And I suppose that brings a lot of questions, like maybe first question that I have to Étienne is, have ever writers been right about something that we see right now in technology?
Let me press the button. Does it work? Yeah. Again, well, a lot of things that we see in science fiction were made happen because of science fiction, in a sense that pretty much all the technology, I mean, we have to imagine it before we're created. One author that is considered to be very good at trying to at least foresee the future, maybe not predict, is H.G. Wells, who was right about the beginning of the Second World War. He wrote in 1936, Things to Come, and he was right about the beginning of the Second World War, give or take a few months. So sometime again, it's about luck, but science fiction is important because the vast majority of innovation that we have is indeed coming from science fiction, about imagination, about this kind of proactive imagination. So again, it's just like it's difficult to say that we prevented something described in science fiction because we were aware of it, it's also very difficult to really give the paternity or maternity of either an event or technology because science fiction. I mean, it's also like saying science fiction was born at the end of the 19th century. Usually people work in science fiction, give me a lot of flack because they say, well, yeah, but before this you had Mary Shelley, before this you had this, and so forth and so on. So it's a big, huge environment, and science fiction is just one, it's just one way, very influential, to speak about the future, but it's not the only one.
Thank you.
Thank you. My question is a question to a question. Like, instead of framing this as what if machines outsmart us, how about like what if machines will dumb us all, kind of? Because at the end, like I'm a technology lawyer, so we studied this all of and how the smartphones are already making us dumber because of the lower reading levels. Children cannot even focus on reading books anymore. So they cannot even in the future can check the output of what AI would come up. And in the bureaucracy, heavy bureaucracy in EU, the officers are already relying on shadow AI techniques, so they are not already using their own intellect anytime. So my question is, how are we going to bypass automation bias? Like that's.
Yeah. So it's something that we discuss often, and so it's basically skill atrophy, right? So if you don't do something, if you don't do it enough, you're not able to do it, and then in the future you won't have anything like that. I think it's useful to look at the past and what happens in similar situations. So once you have cars, people don't have to walk anymore, and then they lose the ability of walking. I think all of these things typically change. So revolution changes our relationship with the world around us, and so we need to find new ways to do those things that we weren't doing before. What I see with the current generation of students is that a lot of them care a lot, for instance, about their physical activity and their mental activity. And so it makes it the distinction sharper. Sure, you can use AI for everything. You started by saying social media, right? And so yes, absolutely, it's terrible. You can keep scrolling and keep scrolling. But people are becoming more and more aware of this, and also opting out of these things in certain circumstances. So I don't think it's just a doom and gloom scenario, but just an adjustment to a new reality that can even make it more clear what you need to exercise and what kind of skills that you want to have. But this will be a personal choice, right? So you will really need to say, for these kind of things, I'm not going to use AI, and also for this time in my life, I'm not going to be on social media. I mean, as an example, I don't watch YouTube anymore. I don't have any social media because I can't live with it. Yeah.
So let's take this philosophically. Based on Louis Althusser and the ideological state apparatus, they already designed us as human beings to function in the system, right? So if they nudge us enough to function that, oh, the AI is it's giving the best output, you cannot even challenge it with your brain system, and this is going to happen. This has already happened. People are bringing out AI output homeworks, and the teachers, because out of time, make the AI check. So this is AI is checking each other at the end. And what I'm saying is 20 years later, we are not going to be able to like do the things you said like autonomous way, you know. Like we will be programmed to think that the AI is already outsmarting us.
Maybe just to comment on this. So one thing, I didn't mention it, but I referenced it in the slides, in my slides. There's another 2025 study about descaling from students who were overusing ChatGPT 4.0, I think it was. So this came out in, I think, November of last year, something like this. It's not peer-reviewed yet, but it was released on ArchiveX. And it is a big worry. But to shift context a bit, a very similar argument was made about painting when photography was being developed. A very similar thing was being argued when slide rules were introduced into schools. You know, we haven't lost the ability to do things like arithmetic longhand. We haven't lost the abilities to paint, even though there are these tools that are very widespread, and now even better when we think of like calculators instead of slide rules. So one of the things to kind of counterbalance the, we'll call it doomerism that you were after, is, and this is just reiterating Emmanuel's point, like as long as we're careful, as long as we're conscious, as long as we're engaging with these things in a very clear-eyed way, then I think there's going to be at least space for us to, again, the way that I was talking about it, protect our agency in these ranges. Now, there's going to be a lot of forces working against that for monetary reasons, for capture reasons. But again, working against doesn't necessarily mean that that failure is inevitable. I think that's the kind of thing that we need to kind of keep in mind here, right? As long as we have some kind of cognizant of the problems, we'll be at least able to push back against it. But I very much understand and appreciate the worries.
Thank you. So my question is also for Nathan regarding those relationships between humans and AI's models, and the best one is adult-adult. I can agree with that. However, in the adult-child relationship, which we also have in society, we talk often about consent and how children cannot provide consent, and we choose a certain threshold since the child becomes an adult. Will it become a threshold for when people can make decisions for their agency? Is there going to appear, like, do you believe in a threshold? Do we believe that we should invent a threshold? Because right now we use these thresholds in our society for other decisions.
Yeah, I think there's some very delicate issues there, right? We don't let kids vote, for example, right? We don't let kids make their own medical decisions, for example, right? But what we do is we think about kids as having the potential to develop into these kind of autonomous agents. So we do a very delicate dance between kind of making decisions for them and sometimes, I'm not a parent, so take this, maybe somebody else should talk about this, but trying to kind of guide them as to the rationale for making these decisions, to, sometimes kind of letting them have a say in some of these things. And there is a sense in which, yes, we've got to be careful about where we're going to draw the threshold, as you were putting it. I don't think that necessarily undermines the kind of broad approach that I was after. I think that that's the next question that needs to be addressed, right? When do we kind of draw the line here? My broad approach would be to be as extremely generous as possible. And that's something for other contexts I'm very happy to do as well. Exactly how the line gets drawn, it's a tough question, and I don't have a perfect answer for that yet. But it's a good challenge, so thanks.
Thank you. I would have a question that I would ask each of you to answer separately from each other. The question is, if there would be one thing you would change about the education system as a whole, let's take it as broadly as possible, whether academia or primary school or whatever, what would it be? And in particular, the context is I'm 30 years old. I would say I'm probably millennial, I guess. I grew up with this meme going around all the time that why do schools teach us math and geography when I should learn how to do my taxes and fix my car? And I think we're at another shift of the skills that are needed to be learned, such as what does it mean to have agency? What does it mean to be a good human person? Whereas geography, I can just ask AI, So in that context, what are the main changes you would expect or request of your education in the next couple of years?
Press my little button. Yeah, there we go. I'm glad you asked. We try to change it. For instance, right now, I'm with you. I'm very happy, but I was supposed to have a meeting about future of education. I have some students which are working on this. We work also with the university, with different organizations. And one of the things that we work a lot on right now is one of my pet projects, which is to say it's great to have a lot of young students on a campus, but how about them 40-year-old, 50-year-old? And this morning I was speaking to a student of mine And she was saying, well, I started saying, well, it's part of what I want to do, bring some diversity on campuses. I like young people, obviously, but why not 40-year-old, 50-year-old? And I'm thinking about my mother, for instance, who got a master's when she was already a mother of 3 and she was 45. And she said it was very difficult because the vast majority of people that were in the same room, they were 20, they were talking about how smashed they were during the weekend, these kind of things. And, you know, she was mostly talking about education, so it was difficult. So first thing, bringing diversity to campus, that's what I would very much like to do. And I'm very happy that our university now is also moving in what is called the triple L, so lifelong learning, always acronyms, universities like that. That's one thing. The second, I disagree with this meme, obviously, because I'm a historian, and I can tell you one thing, which is that you continuously learn about it. So when you say I can ask my AI about geography, yes, but the AI is going to basically do what Wikipedia does, so it's not awesome. What we see, and again, stemming from studying also science fiction, bringing science fiction, is that the most important thing, the only way to kind of save university is to keep the human factor. In a sense that the most interesting for us teachers, I'm not sure I speak for you, but it's when we interact with students. Lecturing is interesting, I like it, but when we have interaction, for instance, the lecture is over, and then there's always this student saying, I have a question, and it sounds like a 1-minute question, but we spend 20, 25 minutes about it, and that's precisely what we like. So keeping the human factor, maybe reducing the lecture hall, saying, well, for basic stuff, I don't know, I'm going to say something, make enemies, but for marketing, you can do it with AI. But when it comes to things which are more humanities or literature or anything, things which are a bit more complex, then this is where we will bring back the human factor. So long story short, once again, more diversity, understanding that it's all about lifelong learning, that we're there to learn, and sometimes you're 18, you don't want to learn, but sometimes you're 45, you want to go back to your campus. And the second thing, to be sure that AI doesn't modify, because per the question I was asked before, I didn't say anything because I have no idea. Usually we say innovation like the elevator didn't replace the stair, but now we're facing something, we have no idea what's going to happen. So I have no idea. The one thing I know that cannot be replaced for now is really the human factor. This is the way.
Yeah, I agree with many of the things, and I like to also look at extreme cases, what works well and what doesn't. And when I think of students, for instance, when you look at extreme cases of students who are very happy, who are engaged, and you look at what they're doing, you're seeing how it should change. So these are students who come to you, who make use of all of the available resources that a university has to offer, who are greedy, who make their own plans, who are autonomous. I think I often compare it to a fitness club. You can enroll in a fitness club and go there and set your own targets and your own goals, and it's you who has to work to do these things. Or you can enroll and never go there, right? So this is really also about the relationship you have with that. And then that brings us to what should we do? Should we be there and try as best as we can to teach the material that's available, explained on YouTube, for instance, by 3 blue, 1 brown, to have just one channel? Much better. No, we shouldn't, right? So we should make use of all of the available technology and material that is there, bring it in, but we are there to help, to coach, to make sure that students stay on track and that they are able to reach the potential that they want to reach at their stage in life also. So if you don't want to be there, and if it's not the right time to do things, absolutely do something else. But when students come to university, I think we should be there to help them reach what they want to reach, and I'm kind of sure that this is where universities are going to. That's the direction.
So I've actually written a white paper on this. I could talk for an hour. 2 things: make it free, no grades. I did all pass, no pass in my undergrad. I thought that was the perfect environment to actually study. And then with regards to the cost, I think, especially not necessarily in the Dutch context, but in lots of other places, that's a huge factor. It motivates a poor attitude where it's a kind of consumer attitude. they're paying all this money, I should be getting a good grade. Why am I getting a B, for example? So yeah, I think those are the two.
At the end of the first presentation, we ended on this AI 2027 slide, the scenario where you get eventually to superintelligence or SAGI, if you will. And I've known the authors behind that for several years now, and I've seen them like 5-10 years ago as well, see them make predictions that ended up being pretty prescient and come true. What if they continue to be right, and this is really the world we live in, even though it might not be 2027, it could also be 2037? At what point does society really start to organize and start to prepare for this? And how do you prevent getting frog-boiled in a scenario where right now it's still speculative, so it doesn't really make sense to have any kind of severe policy action, but then at some point, if the machines do outsmart us all, it might be too late to really still steer the technology?
No, I think the answer is that it's here now, and you need to start thinking about how you're going to organize things now. Because, for instance, in coding, there's a recent study that came out that shows that expert coders, so senior programmers, use more AI than junior programmers, and they're also probably because they're able to use it more effectively than junior programmers. So there are transformations in a few industries right now where it gives you something that's actually useful, not just producing TikTok slop. I mean that's of course also something that you're gonna have. You're able to do this, and then if you have somebody like me, I keep scrolling. That's why I can't have it. But you need to start thinking about these things now, and not far into the future. And the timelines are getting shorter, right? Because you will also have more certainty about the abilities that you have now, and what can happen in the future. So I think we need to look at policy and regulation on very, very short time frames.
I think my question kind of links to that, what you said. Do you think agency is, and what students want also, stronger than human laziness? Because AI is so easy, and it's so easy to give in the same way it's so easy to give in on social media and things like this. So, and I also actually really like the question about education. Do you think then agency should be taught really early on, because then AI is already used in high school, etc.? So, yeah, what's your point on how agency is strong around also just the pure human factor of we're just lazy, we like doing things easy?
Yeah, I think that's a hard thing, right? But being moral is often a hard thing. Doing the right thing is often a hard thing. That's a cheap answer, but I think it's the right answer. Yeah, I don't know, man. If I knew how to beat laziness, I probably wouldn't be here right now. I'd still be making way more money and be on a much bigger... No, you see the joke.
Yeah.
There's a sense in which accepting human fallibility is actually an important part of this, I think. So allowing people to make the mistakes is, I think, a very deep and important part of this concept of agency, of autonomy, which is another term that I might use here. And so there's almost a sense in which I don't want to try and beat the laziness. I just want to give people the opportunity to try and do that. And then to come back to the educational question, which I think is a good one. This kind of comes back to the lifelong learning stuff. Put really bluntly, I think a lot of times when people rock up to university, they're too young to really get a proper grip on what the hell that means. And not to knock anybody, I know a bunch of you guys, right? And are still quite young. What I mean by that is a lot of the stuff that actually kind of tests you, that helps you kind of grow and develop in that way, is gonna be life experience. And that's not something that I think we can we can teach you. Or we could, but we do that in really unethical ways. So that's the kind of worry I would have there. This kind of ties in again with the free and no grades, because it encourages people who are later in life to maybe come back and like engage in this stuff and think about these kinds of things in a much more, no, I don't want to say informed, because that's totally the wrong word, but with a body of experience that then they can reassociate with. So those are flailing answers, but I think those are along the lines of something like the right answer to that. Yeah. Thanks for the question.
It's more of wondering rather than a question, to be honest, but I would like to pass it right now, which is, I see all the time, you know, correct me if I'm wrong, that the advancement and the all this high tech we are using on our daily basis is led by few companies and from few countries. Should we be concerned about that?
Can I answer that? So yes, absolutely, and so that also connects to my previous answer. We should not be asleep at the wheel. We need much more autonomy for our infrastructure in Europe specifically. So there's terms such as digital autonomy and digital sovereignty. We don't have a lot of that now, and this is something that we absolutely need to change, because I mean, sorry? It's us. I mean, we have to do it, and that's just okay. It will be us. So yeah. Yeah. I don't think you're much older than I am. So so yeah, but I don't think, no, we don't have an opt out here, and so we have lots of initiatives underway there, but it will also require a lot of investment in that, because that there's no free lunch in that, and so these are also hard decisions. If you don't want to be dependent on things, well, then you need to build things yourself and invest in them, and that leads to all kinds of social changes that we may not be so happy about.
I have a question about educational system regarding that. Do you believe that once SAGI is reached, academia will stay the same with PhDs, postdocs, professor positions, and all these things, or will those disappear?
I thought there may be science fiction in which there's no more professors and.
Well, yeah, there's a bunch of it, of course. I mean, you can always find some different universe in the future, but I mean, I don't know. I think it's more a conversation we should have. I think that, yeah, the doctorate are there to stay, because also you have different kinds of scholars. You have people that know a lot about little thing, and you have people who know a lot about general. So you have so many different type of people. Like there's a lot of difference between, for instance, a PhD, a doctorate in philosophy, and doctorate in history. And for instance, in my department, I work only with sociologists, and sometimes it's very difficult to understand what the hell they mean. I have no idea how they were trained, but they were not well trained.
So maybe they speak Dutch.
Yeah, probably. No, we're all international. I mean, there's like 2 Dutch people which are there. But I think, I want to think that, yeah, because right now, we see like we're talking about the Silicon Valley. You have the big companies which are really punching very hard, and Google is saying, what you learn at university, it takes 4 years. We can teach you in a month, and it will be cheaper, and it will be awesome, and it's about coding and stuff, and that's it. And so we're already under a lot of pressure. Plus now we're lucky because we have a new Minister of Education in the Netherlands since last week, so she's coming from Maastricht, which is great. But before this, there were a lot of people who didn't like us, like Wilders, among other people, who doesn't like university. He doesn't see the purpose of university. He doesn't understand why we even exist. So there's always a lot of pressure, and year after year, decades after decades, centuries after centuries, we're always under a lot of pressure. People don't like university. Sometimes they don't understand it. Sometimes they're right. They see it as a place where people are a bit arrogant, probably always on conferences in Cancun, you know, and they say, well, I cannot lecture this week because I'm going to a very important conference, and my carbon footprint is none of your business. But yeah, we should indeed change. It's going to be another thing is going to make us change. We don't really know how, but it will definitely have an influence for sure. It has already.
So I remember that I actually thought about this, and I have kind of a provocative answer, and that is that all PhD students and all researchers think they are doing the most important thing in the world, and that their research that they're doing is really okay. This is why you should have them, because they're working on really important stuff. I don't think so. From my own experience, I always thought that when I was doing my PhD, like it's the most important thing in the world. But there is a really good argument to be made that in a society you need a particular reservoir of people, and I'm not talking about like it's not the gold class of people, but that where you transmit a certain way of doing things and that are able to connect to your whole cultural and intellectual heritage. And you need a certain mass of those people for a stable society. So I would argue that there is really something to be said in favor of maintaining that class of people who are doing things that they think are really important, but the real importance of having them is to have some continuity in that system. And that's the risk when you say, okay, let's replace all those people by a super intelligence, then you lose that value as a society. And I'm not sure of this, but I think when you look at how much societies invest in education and in research, that also has a relation to the amount of stability that you have in a society.
I agree broadly with everything. I think I would put it not in terms of importance, but since I certainly didn't think that my PhD was very important, I thought it was really interesting. And I think there should be a space for just knowledge for knowledge's sake. Now, should be and will be are very different things. I fully expect pretty bad consequences, mostly with regards to funding for higher education and a big push for practical higher education. I suspect there'll still be some places where it's purely the sort of ivory tower academia kind of things, which I think are good, but I'm a philosopher. But I think a lot of higher education is going to become much more applied, for better or for worse. Not to say that those are necessarily bad things. I just think that, yeah, there's something that's going to be lost. That's sad to lose.
So I have a question regarding...
Sorry, before we start, I just want to recommend a very cool website called willrobotstakemyjob.com. And it's quite interesting. So you type the kind of job that you want, and the algorithm working with database is going to tell you whether or not you will be unemployed. And so, for instance, my university is known because of the School of Economy. We have 7,000 students. And if you go on, well, robots take my job, and you say economist, they say, well, the chances that you have a job are like 30%. So we will have to deal with, I don't know how many students that makes, but not that many will actually be economists. So if you have a lot of questions and you're not too depressed, willrobotstakemyjob.com. That was my recommendation.
So I have a question regarding the regulation development for AI. We were talking about this in the question before this. So regarding the speed of development we face with AI, I'm just a bit concerned if we can keep up with regulations to stay safe, because that would be my personal concern, being reliant on the producers and developers that might not always have the most positive intentions. To only rely on morality in our capitalistic system, I'm not very trusting that. So what do you think about it?
Okay, I'm no expert at all in this. I think there's a lot of research, not specifically on regulation, but on AI safety. So how do we make this work well? How do we align the models that we have with human values? I think that it's good to try to regulate some things, but I'm also concerned that over-regulation may stifle innovation. I know that that's a classical argument, and that you may not like this, but I think we're also in a world where we will need to do certain things with AI. It's going to be inevitable to stay competitive in some ways. So I think we need innovative ways of regulation, because adding regulation onto regulation and onto regulation and making systems more and more and more complicated is going to be highly disadvantageous for us, I think. And that doesn't mean that I think that we should be like the US or have everything completely free. But I also don't think that keeping on regulating in the way that we're currently doing is a solution.
So this, I think, it's time to finish the discussion panel. Again, I would like to thank all the speakers for. I mean, it unfolded pretty rapid with your ovation, so I think it's time to move to bar, which I highly encourage to do. If you got any more questions, I think, and I hope, that our speakers will be present there, so you can ask them in more private manner and maybe receive more honest answer. You never know. And yeah, thank you very much for attending on behalf of mine, Studium Generale and Enigma, and see you there.